All right, we're going to begin our thermochemistry unit, and thermal means heat, so this is heat of reactions. We're going to tie this in with thermodynamics. We kind of started thermochemistry a little bit in Gen Chem 1. We just did like specific heat problems. We're going to be a little bit more specific. This is more of heat of reactions, and the first one we're going to introduce you to is the term enthalpy. Enthalpy is amount of energy, so it's an energy measurement. So we're going to start to see kilojoules as our unit, the amount of energy that is either released or absorbed. So we're talking endothermic or exothermic reactions when bonds are broken and new bonds are formed during a chemical reaction. So what we're going to see is the delta. Again, delta means change in the enthalpy, which is letter H, and so we're going to see another word that's very similar to this coming up called entropy. Enthalpy is H, think of heat of a reaction, and RXN is just the abbreviation for reaction. If delta H comes out to be negative delta H means that the reaction has released energy in the process, and so this would be an exothermic reaction. That means it gave off more energy than it had in the beginning. If we get a positive enthalpy or a heat of reaction, that is an endothermic reaction. Oh, I can't spell endo all of a sudden. Hold endo. So that's going to be important. That's going to stay with us for a while. And so we're going to be seeing a couple different charts. And again, this worksheet that I'm writing on here is on the Moodle page. If you want to stop and go print that out, you can. So there is this, we're going to see two different types of charts. And so this first chart that we're going to be looking at is called heat of formation or enthalpy of formation. So you're going to notice that you see that little F right there. So enthalpy of formation is the change in enthalpy for 1 mole of the substance made from its elements. That's kind of important. So basically it's, if I were making water, it's how much liquid water, how much energy would it take to make water from oxygen and hydrogen, okay? And so this is always going to be 0. Oh, we're having a moment here with my board. 0 for the most stable form of any element. With that being said, so pure elements, let's pick oxygen for a second. So O2 as a gas, we're not going to see it in the chart because that is the most stable form. Basically, we're saying that it doesn't take any energy to make oxygen from oxygen. So in our data table, we're not going to see our data table like this. You're not going to see pure elements. Okay, so you're not going to see any pure elements. So later when you're working problems, you're like, oh, I don't have oxygen. Oh, I don't have nitrogen. Well, if it's a pure element, it's not in the chart because it's 0 for enthalpy. Now, entropy is going to be different, but enthalpy. And the reason that it is, it doesn't take any energy to form, because that's why it's called heat of formation, form those pure elements from the element itself. Okay, so we're going to use these heat of formations in order to determine if a chemical reaction is an endothermic or exothermic reaction. And so the way we do that, we've got, I've just got a picture of my data table there. We're going to use that here in just a minute. So you can see all these different ones. And I will give you these heat of formations unless we're trying to solve for one. Okay, so here's our first example. So we're looking for the enthalpy change for the combustion of methane. So we have this nice balanced equation here. Here is our first formula we're going to be using. So to find the heat of formation or the change in the reaction, this little circle means it's standard condition. It says not is what it stands for. So we're going to be calculating at standard conditions. Standard conditions means 1 molar, about 1 atmosphere, 25 degrees Celsius. If we are not at 1 atmosphere, then things kind of change. So this crazy symbol here that you may have seen in some of your word processing classes means the sum of. That means just to add up. So we're going to add up all the formations for the products, and we're going to add up all the formations for the reactants, and then we're just going to subtract them. So it's products minus reactants, and it's like final minus initial because it's changing. So these are really super easy. So I want to do these. And then the second type I've added in last semester because in organic you do something a little different. So I wanted to show you when you're not using a formation chart what you do. So when you're using a formation chart, it's always the product side. Remember, this is the product side. Over here, products minus reactants. All right, so let's just begin. So to find this change in, goodness, my board is not doing well. To heat. All right, I'm plugged in and everything. I don't know why it's doing that. It's not like any of the letters today. To find this, I'm going to take the sum of, that little N and M just means we're about to use coefficient. Oh, that just really looked ugly there. Okay, so we're going to do, maybe we're not going to do anything because this board is not wanting to cooperate. All right, we're going to do products minus the sum of the reactants. Okay. And these again are super, super easy to do. I'm going to probably suggest you do them separately, but you're welcome to not, but you are safer to do that. So I'm going to do the sum of the products first and kind of get that answer. So the way I do this, we start here. I've got 1 carbon dioxide, so I'm just going to write 1 for emphasis. So I'm going to get that off of there. I meant to put my sum here. So I'm going to sum up 1 of my CO2s. So I'm going to go to my chart and look up at my chart and find CO2. Here's CO2 right there. So it's a negative, so this is exothermic for forming that CO2, negative 393.5. So a negative 393.5. I'm just going to put kilojoules. It's really kilojoules per mole. This 1 here is the 1 mole in front of that. So I'm not going to worry about that cancellation of the mole, but it's going to end up with just kilojoules for just a second. And so then I'm going to add, because that's what this weird symbol means, 2 waters. You have to be careful with water because water in that chart is in melting place. I want water as a liquid. Let me go back to my chart and find water. See how there's water as a gas? I don't want that one. And water is a liquid right there. Negative 285.5. And so we're going to have 2 of them. And you've got a negative 285.5. 285.5. I wrote 8 on my piece of paper. It's 0.8. 2.8. There we go. Kilojoules. I have on my piece of paper, right? And I'm just going to figure out what that is. And this would be safer just to do that. These are going out 1 decimal, so I'll go out 1 decimal. And we get negative 965.1 kilojoules. That was this product side over here. I'm going to now do the reactant side. On the reactant side, I have 1 methane. And so methane in my chart is very top, negative 74.8. And then if I go to my chart, I've got 2 oxygens. Oh, I went to the next problem. 2 oxygen, but I don't find oxygen in the chart, so I can't do this problem. Remember, pure elements is 0. Pure elements, oxygen there being a pure element. So I would suggest you don't even put plus 0 because I have students that put plus 2 times 0 and for some reason they get 2. So if it's 0, I would tell you not to put it in there. You would be a little bit safer there. So negative 74.8 kilojoules. Now, to solve this, it is the products minus the reactant, so negative 65.1 kilojoules. That's a really bad looking J there. Minus the negative 74.8 kilojoules. And you don't have to rewrite it. I'm just doing it for emphasis here because it's products minus reactants. You just subtract those and we'll get a negative 890.3 kilojoules. And so is that endothermic or exothermic? This is a negative number, so this is an exothermic reaction. Okay, so super easy. If I have heat of formations, that F, heat of formation, I'm going to take the product side minus the reactant side, and that's going to get me my answer.